Hi everyone, good morning, good afternoon, good evening. Okay, I think we can start. In the last session, we were talking about the functions, right? So there are different types of functions, system functions and user-defined functions. In the system functions, we have aggregate functions, date time functions, string functions, and etc. We saw some examples for these. And in the user-defined functions also, we have three types: scalar functions, inline table valued functions, and multi-statement table valued functions. Right. So system functions are the one which are already present in the SSMS, right, which are available in the SQL Server itself by default. Okay, we just have to call those functions by the name, and we can specify the parameters for those functions and we'll get the result. That is system functions. Whereas user defined functions are the ones which we create. As a user, we create them. Okay, when I say we create, we'll also have to create the logic for that function also. Based on whatever logic we write inside the functions, that function will behave. Okay, so we created this simple function, scalar function, which added two numbers and return that value whenever we call that, right? Right, when I execute this, it gives me a result of 30. Similarly, here we are hard coding the value, whereas I created one more function where instead of hard coding the values, I've created two parameters to this function. Right, and these parameters are passed. These are also called as arguments. These are passed when I call a function like this. Right, so when I call a function like this, this value is assigned to this argument and this value is assigned to this argument, and from here this will be assigned to this and this will be assigned to this, and the result is returned back to this function and from here to here. Okay, this is how this value assignment to the parameters will work. Now let's see some more examples of this. How can we use this on the table? So now this is kind of a independent function, right? You can without referring to any table, you can just call it. Let me create one more function to demonstrate that. Let's say I call this function as create function concatenate string. Okay, I add two arguments, two parameters to it. One is first string, the data type for it is varchar. Second string 500. Okay, two parameters I have created. And for a function has to return something mandatorily, right? So I'll have to write returns keyword. What it returns? It returns a string. What is the body of the function? The logic. We have to use this use as keyword and begin. From here our logic will begin. We have to use end. Within begin and end, we have to write our logic. So what is our logic? Return. Inside this, I concatenate these two strings. Select first string plus is the concatenation operator and second string. Right? So I create this function. Now select. We'll have to specify the schema name for the function, that is mandatory. Let's say I specify Praveen as the first string. If I execute this, it will concatenate these two values and give it as this one. Okay. Now what I want to do, if you remember earlier when we were getting the data from the person table, we were concatenating the first name and last name to make it a full name like this, right? So instead of doing it like that, I can call this function. For example, select star from person dot person. Okay, so here I have first name and last name. So in the select statement, I know how to concatenate it, right? So now instead of that, what I do, I call this function here. For this function, it has to take two parameters, right? So for that parameters, I'll supply the column values. So first name I have, this is first name, comma, last name. Now when I execute this, I'll give a name to this column. Here, I'm getting this full name. For this full name, I am passing the parameters. I'm passing the column names from this table as the parameters to this function, and it does the logic that I have written inside this function. Okay. Similarly, let's say in this table, we don't have the date of birth. If at all we had the date of birth, we can also create one more function to get the date differences, and we can use it here to find the age. Okay, for example, let me create one more function. Create function, date difference, and I'll create two parameters. Maybe I'll create only one parameter. Only one parameter is required, right? So I'll add start date and data type. We can assign date also, but I'll just assign string. That should be fine. And what it returns? Char again as begin end. Inside that I write return select there is a function called datediff, right, which will give you the difference between the dates. So what is the syntax of it? Datediff interval, comma, start date, comma, end date. Okay, interval is in, I want to get the difference in terms of years. So I'll type year here. And what is my start date? Start date is this one which I pass. And end date would be, I'll just use get date, right, which is my current date. Okay. If you just use your arrow keys on these parentheses, so it will show you where it is closing. It is opened here and it is closed here. It shows its respective other parentheses. See here, it is opened here and it is closed here, like that. Now I'll execute this. So here for this, let's say date that I give is 2020 0101. This is my start date. I just need to pass only one parameter, right? So it takes only one parameter. Inside this function, I'm calculating the date difference with respect to current date. So if I execute this, so it is 4 years, right? The difference between these two dates is, this date and the current date is 4 years. Here instead of year, if I choose month, quarter and all, it will show you the difference in those values also. Now, so in the percent table, let me call this function. Here we don't have the date of birth, right? If at all we had the date of birth column, we would use date of birth column. Instead of that, we have, I think, last modified date, right? Let's use that. Let's consider that as our date of birth column for now. Okay, it is not last modified date. One second. It is just modified date. Yeah. So I call this as right. Now I get the difference between date modified column value and get date. Okay, so this is how we use functions, and these are the scalar functions, as in it will only return one value. Okay, so it's not that you should have only one statement. You can have multiple statements, SQL statements, but at the end it has to return only one value, single value. That's why it is called a scalar function, right? This one. Next one is inline table valued functions. What are inline table valued functions? Syntax is totally different in Postgres. Yes. So syntax can be different because it depends on what database you're using. It will be different in Oracle. It will be different in MySQL. It will be different in SQL Server, and it will be different in Postgres as well. There won't be huge differences, but there will be little difference based on that database's architecture and all that. Okay, so in inline table valued functions, what happens? These functions will return table itself as an output. Okay, for example, see if I execute this is my scalar function, right? If I execute this, it is only giving me one value. Even for this, when I use it with the table, it is actually giving one value only. If you see, if you notice, this is just one value, this is another value, this is another value. For each row, it is returning one value. Since I'm using it in the table, it is showing the entire table, but the value that this function is returning is only this at a time. This value, next this value, next this value, next this value. That's why it is scalar function. Whereas here in the inline function, the function itself will return the table as an output. Okay. For example, let me create a function. Create function. We generally denote functions with fn as a prefix. Fn employee. If you don't have any parameters, you just need to use open parenthesis and close parenthesis. And here, function has to return something, right? Either scalar value, or in this case, it has to return table. So we need to specify what it returns. It returns a table as, you can use begin and inside this, and this begin end is not mandatory if you just have only one statement. If you have more, then you can use it. But let's make a habit of using it always. So this returns select star from person, for example, person.person, right? I have to close this parenthesis, create this function. It says incorrect syntax near returns. Okay, it has to be here, it is returns the keyword, here it is just return. That's what is this error. One second. It says a return statement with a return value cannot be used in this context. Incorrect syntax near begin. Okay, one second. Let's remove begin. It is showing error at the begin, right? Yeah. I'm not sure why the begin and end is giving error, but if you have just one value, I mean one statement, you can also skip those begin and end. So now select star from, instead of the table, now I use this function. What it will give? It is giving the result as a table, because this function returns a table as an output, and inside that function I have written a logic to show all the records from the person table. It is as same as using select star from person.person. here. Both are giving the same example, same out result. Okay. But in this case, it is just a simple example. So instead of creating a function to show this, you can just directly write select start from person. Okay. Let's make it little complicated. I'll create one more function. Create function fn sample function returns table again as file type return within the parenthesis what I write, let's say above we had some query, right? Yeah, so here this join will use to get the details. Let me type select. Let's say there is sh let's first use tables. Select from sales order header SOH join means inner join salesperson SP on SOH dot sorry, this has to be sales order header, not detail. Salesperson ID. We don't have the salesperson ID in the order detail. That's why SP dot business entity ID. You know how to get the relationship columns, right? Based on the primary key and foreign key. Business entity ID. Then I'll use join human resources dot employee EMP on EMP dot business entity ID equals to SP dot business entity ID. Then finally, I'll have to join this with person dot person. See, what I want to do with this query is I want to get the sales by year by a salesperson. I mean, for each year, for each salesperson, what is the sales? Okay, so to get the salesperson name, a salesperson name is present in the person.person table. But to reach to this, I have to use all these tables. First of all, my salesperson ID is present in the sales order header, which I have to join with the salesperson table so that I'll get the business entity ID of that salesperson. That has to be joined with the human resources employee table, this business entity ID with the employee table business entity ID, so that we get the business entity ID, which we can use to join with this person table where we have the actual names of that employee. If I just do human resource dot employee, so let's start from here. We don't have the names of those employees. We just have the national ID number, login ID, organization node, organizational level, job title, birth date, marital status, gender, hire date, salaried flag, vacation hours, sick leave hours, current flag, etc. That is the reason we'll have to join this with the person table to get their names. Okay. See, in the person table, we have both employees names as well as the customer names and others names also. So that's why we'll have to join it with the employee table so that we get only the employees names from this person table. Okay, so that relation you can get it from this table. First go to this table, find foreign key relationship on salesperson table, salesperson ID. It will take you to the salesperson table, and from here that business entity ID, just look where it is pointing to employee, and the employee's business entity ID will have a foreign key relationship on person. Person per on P on P dot business entity ID equals to E dot EMP dot business entity ID. Okay, now I've given star here. I'll select whatever columns I want. For example, SH dot SOH, SOH dot order date, comma SOH dot, let's say I want to see whether it's online order or offline order. Online order flag, SOH dot salesperson ID, comma. Here I can use my function. Let's say I have this first name, last name, right? I can use this string concatenate function to get the full name of the employee. And here to this, what I pass P dot first name, comma P dot last name as full name, comma, let's say I want to get E dot login ID, that is EMP, right? Employee dot login ID, EMP dot, let's say job title, then SH dot SOH dot subtotal. Okay, so if I execute this, I'll get these values. Maybe the login ID is not required. I'll just remove it. Okay, this is the data I get. But here, if you notice, I'm getting all the detailed data for this guy, writer. So for each of his sales, I'll get individual records. So I have to group by, right? I have to do a group by. So I want to see this information by year, right? So I'll use year function, year of sales order date. Then I want to do this sum this column as subtotal. Now, what is the thumb rule? When you use aggregate function, all other columns used in the select statement other than aggregate function should be present in the group by. So I'll have to use group by function. Group by clause. And one more catch here is that in the select statement, we have used the function, right? So you can't use the function here in the group by actually. So what rule says? Rule says any column that you use in the select statement has to be either part of the aggregate function or should be part of group by. So instead of, if you use the function like this here in the group by, it won't work. So instead of this, what you should use, you just need to use the column names, not the function. That's what it says, right? It talks about the column. The column has to be either in as part of the aggregate function or as part of the group by, right? Now if I execute this, okay, I will give name to this column here. I'm just running the inside query. Okay, I'm not still, I've not just created this function yet. I'm just executing this inside query and checking if it is working fine or not. Okay. Now, by year, I'm seeing the sales data for each of these salesperson. Let's say this guy Stefan. In 2012, he has made this much of sales. In 2014, he has made this much of sales. In 2011, he has made this much of sales. In 2013, this is the sales. Similarly for other salespersons. Okay, so now I'll create this function. Function is created. So instead of running this statement always, you can just refer to this function. So you can just do select star from now it will give you the output of this. Where can you find this function? Even if I close this window, this query editor, you can go to the databases under AdventureWorks 2022, like in whichever database you have created it. Go to the programmability. Under that we have procedures and function. This is the one. Just open the procedures. Here we have table valid functions, scalar valid functions, aggregate functions, and all that. So if you see the scalar valid functions, so these are the scalar valid functions that we have. The date, def, concatenate string, and all that. If I go to the table valid functions, fn underscore sample function is available here, and similarly fn underscore employee is available here. Okay, so anytime if you want to see the, let's say I've closed this for example. Okay, so if you want to see the definition of that function, you can right click on it, click on script function as, you need to script it as create, right? Create, alter, whatever you want to do. I want to script it as create statement. So it will show you. Sorry, I got this one, right? This function. You can see how big this function is. I'll come to this later. Let me first open this function. This is what we are talking about. Yeah, this is the function we just created. So you can always see the definition of the function, which is once you create it, it is always there with the SQL Server here. If you want to alter this function, what you need to do? Just type alter key or alter keyword, or you can just right click on this function. You can click on modify also. If you click on modify, it will open up here with the alter keyword itself. This is one way. or you can simply right click and script function as alter to. If you click on it, it will be the same thing, and modify whatever changes you want to modify. Let's say for example I change it to order year instead of just year. I'll change it to order year, and it is alter key is already there. Just click on execute, so it is altered. I'll close this. Now if I do select star from, see here, now the column name is changed to order year, but here it is still showing year because we had opened it earlier. That's why. So let me close it, refresh this, click on script as create to. Now it is changed to order here. This is how we alter the functions. Same way for altering anything, altering the views, procedures, functions, etc. Okay, and there is already one more function available here inside the table alert function as UFN, which means user function get contact information. So this is the function which is already available with the sample database. Here see what it says: returns the first name, last name, job title and business entity type for the specified contact. Since the contact can serve multiple roles, more than one row may be returned. That's why it is returning a table. And you can also define a table here. Let's say in our example, in the sample function, okay, let me bring this. In our function, we are just returning a table. We are telling it to return a table. Whatever output we get from this query inside the function will be returned, right? That's why we're just mentioning table. But in this table, if you notice, in this function, if you notice, they are creating a table here itself. This is of course a temporary table, right? They're creating a table here itself with these columns, and this is the table definition actually. It says columns returned by the function. So here inside that, they're using this logic. If person ID is not null, that means if the person ID exists, then they're checking if that guy exists in the employee also. This person ID, they're checking here. If he exists, then insert that record to this new table that they're creating here using the select statement. Then if exist, purchasing vendor, if this person is present as a vendor, see if this person present in the employee table, then they are inserting this record as a employee into this table. If this guy person ID is present in this purchasing.vendor in the vendor table, then they are calling that contact as a vendor contact and inserting into this table. If that guy present in the store, so they are calling it as a store contact. If that guy is present in the person, they are calling him as a consumer. So based on these conditions, this table, they insert value to this table. Either it will be this one, this execute, this will execute, or this will execute, or this will execute, or this will execute. This is the logic. At a time in this table that they're creating here in the definition, only one record gets inserted based on whether that guy is an employee, vendor, or a store, or a consumer. Then they're returning here. Clear? For example, let's say select star from person, not person. Okay. Here, let's say we have some ID. Let's say we'll enter some random ID. I execute it here. Select star from vendor contact information. Let's say I'll enter 100 as some ID. Let's see what I'll get. So I'll get employee, because this ID is present in this employee table. That's where it is catching up here itself, and it is not, it is checking these conditions also, but it is not matching there. That's why it is only returning the details about that guy, like what is his first name, what is his last name, what is his job title, what is a business entity type. Let's say if I change it to 1000, there is no record. Let's say I do 250, his employee. Say select star from purchasing dot vendor. Let's say what values we have here. Okay, 1492 for example. If I pass this value as 1492, this function, let's see what I get. Four nine two, we're not getting anything. 1 second for the vendor contact. We thought business entity ID and business entity contact BSC. We'll enter one more value. One second. Okay, so if I just use this one 92, I'll tell you where it is filtering out. Yeah, if I use 2090, I'll get this value. Okay, so it was somewhere filtering out in these joints below. This is how the function will work. Okay, this is how you can implement whatever logic you want. Clear? Any questions on this till now? I know it is little difficult in the initial stages to understand, but understand and get used to it. But are you understanding what I'm trying to convey here? Of course, you need to practice on this, then only we will get more hands-on on this. But any questions till here? Yes, of course, you need to practice. Suranjan, syntax is different. Different from where? Where are you comparing it with? I mean, what are you comparing it with? Which database? Postgres, okay. Please share the queries. Yes, I will share. Sorry about the delay on that. So I was thinking to put all the recordings together and share the queries along with that. But as I said, there is some issue with the initial recordings. Microsoft is still working on it. They called me yesterday and they asked me to click on a link to retrieve it, but that did not work. That guy said he'll come back to me today. So if I get that, I'll upload. Else, I'll leave that initial 1 day's recording is missing. Other than that, I'll upload the others and then I'll give you the details about that. Yes, Kuntala, I understand. I've been saying I'll upload the recordings, but yes, I was waiting because if you don't get that initial recording right, you will miss things. So that's why I was thinking I'll upload everything together and give the details. But anyway, so if I get it by today, it is fine today or tomorrow. Else I'll just upload the remaining, and that I'll upload later once I get it from the Microsoft. Okay. Fine. So now this function, if you want, you can also make it parameterized. Okay. So if you want to alter this function, how do you alter? Let's say instead of create, I'll use alter statement. Let's say it is now showing the output for all the salespersons, right? Let's say I want to get only data only for this guy, David Campbell. How do you get it? You can of course filter it, but I'll just parameterize it. For your example, if your requirement is to get only one person's detail at a time, so I'll add one parameter here as at salesperson varchar 100. So here inside the function, I'll use a where clause where p dot salesperson p dot first name equals to this parameter I'll use here. Okay, I'll alter this function now. Here, let's say, what was his name? Steve, right? Not Steve, I think. David, okay. David, Linda, etc. Now I'm getting details only for this guy, David. Let's say there is one more person called Linda. These are the details for Linda. Stephen. Right? Like this, you can also parameterize this. This is about inline table valued functions. Now there is one more called multi-statement table valued functions, right? What is this? As the name suggests, multi-statement. If you notice here, this is just single statement, one statement only, one select statement only. Till from here to it is one statement. That's why it is single valued inline table valued functions, single statement. Whereas this one multi-statement, it's also table valued function, but it is multi-statement, means we'll not have only one statement, we'll have multiple statements. For example, this function that I was showing, this has multiple statements. This is one statement, this is another statement, this is another statement, this is another statement. That's why it is, this is multi-valued function. Let's create one multi-valued functions for us also. Okay, for example, let me go to the my database. Okay, here we have employee details, right? So use my database. So I'll switch to my database for a moment because I want to create a function on this employee table. Okay, here let's say I'll alter this table, alter table, alter table employee. I'll add a column called department. Okay, so there is this department added. I'll update this table, the department column, update employee. When you use update, table keyword is not required. Just update table name, set department equals to, let's say I can just add one single department, let's say as IT, for example, like this. For all the rows, it will update it with IT department. But let's say I want to assign different departments. For example, I'll add a case statement here. Case when name equals to Praveen, then IT, else for others I'll add it as let's say maybe sales, end. Now what happens? For this record it will be IT, and for these remaining two records it will be sales. I execute this, 3 rows affected, it is updated accordingly. Okay, so on this table now I want to create a function, multi-statement table valued function. So create function, call this as fn, let's say salary increment. I want to returns. So here, since it is a multi-statement table valid function, we'll have to create a table here. The whatever output it has to return, so we'll have to create a table, and to that table we have to insert value and we have to return that. Okay, so I'll create a table here. Table definition I'm creating, actually the table that is being returned by this function. Okay, I call this as employee table. Okay, it returns employee table, and the definition of this I have to specify here, like how I define the create table statement. A similar way I have to define it here. Let's say id int name varchar 100 salary. Maybe I'll get the department also. Department salary as int or maybe I'll get incremented salary or salary increment. Int. Okay, this is the table that I want to return from this function as begin. So when you have multiple statements, you have to use begin and end. First I'll insert into this table. This is a new table that I've created here, right? Insert into this is a temporary table. It is available only when you execute the function. After that, it gets removed. Select ID name department salary from which table? From employee table. Okay, so this statement will insert this record, these records to this table. Now I want to apply some logic on this. What is the logic? I want to update this table set salary increment, right? For salary increment, I want to add incremented salary plus salary into 1.25. Okay, I can use a case statement here as well, like case when department equals to IT, then 25% hike, else else 20% hike, for example, end. Okay, so I am adding a logic to increment the salary, then I return it. when I type return keyword, what it will return? It will return this table that I've created here. Okay, let me execute this function. Create this function. Says column name and number of supplied values do not match. Okay, because here we have 5 columns, but here we are only supplying 4. That is the reason. I'll add one more as null. Now it is created. If I execute this, see now I get the salary as well as the incremented salary. I think our logic is little wrong here. We're doing salary plus, that means it is doubling up the value. Let me remove this, alter the function, execute, then execute this. Yeah, now it is fine. For department IT, there is 25% hike, and for other departments, there is 20% hike. So like this, you can apply your logic in multiple statements, right? That's why it is called as multi-statement table valued, because it returns this table. Okay, so why are we creating this table here? Because since it is a multi-statement function, we have to store our values intermediately somewhere here, right? Because I'm storing it here, and then on top of that I'm applying some logic. Then again, on top of this, if I want to apply something else, so I have to, at each step I have to capture that value, capture this logic somewhere. That's why we are creating this temporary table. This is also called as a kind of table valued function, table valued variable, table variable we call it as, but you can think of it as a table itself. We create that table, and to that table we add these values intermediately, and then we'll return it. What is the significance of at in the function definition? So this is the syntax. Like whenever you are using the parameter in the functions or procedures, you need to start it with @. Similarly for this also, this table, this is also like a variable only, right? So it has to be started with @. Okay, clear? If you have any questions, just type in here. Meanwhile, just give me a moment. I'll be back in less than a minute. Okay. Okay, I'm back. Only one question in the chat. Will that EMP table store in DB? No, it will not be stored in the DB. It gets created only when you call this function. When you execute this function, when you create this function, it will just create the definition of this function. Okay, it will not create anything. It will just create a definition of this. When you call that function using this statement, in that case, all of these will execute. So this table, EMP table, will also be created on that time, at that time, temporarily, on the fly. Okay, once the execution of this completed and you see the result here, then this employee table gets vanished. It will not be stored permanently on the database. Only the physical tables are stored on the database, like how you create like this. Okay, if you don't have any questions, let's move to one more important thing, is called as stored procedures. What are stored procedures? What are these and how different are these from the functions? Okay, Atif says set of operations which execute automatically when certain criteria meet. It's Suranjan says it's store as group in RDBMS. Okay. Raghavan says save the code, users reuse again. And Baba is asking the same question to me. I asked what is the difference between function and procedure, and he is asking the same question to me. Anyways, yeah, save and reuse the code, but we can also use the use functions to reuse the code, right? Here also, I have just already saved this code. I can just use it. These functions, procedures, these are used to store your code, basically. Okay, store your code, and instead of executing this entire code every time, you can just call the function name or a procedure name, so that whatever definition you have created inside that will be executed. That is the basic functionality of this. Whenever you create a function or a procedure, the code gets stored in the SQL Server in your database in the programmability. If you create a function, it will get stored in the functions. If you create procedure, it will get stored in the procedures, stored procedure. Okay, only the definition of it is if it gets stored here. Once you execute, it will go search for that function here. Let's say if I try to execute something like this, if I try to execute this, it will fail because it will try to find if this function exists, if this object exists in your database. It doesn't exist, that's why it says invalid object name. Okay, so when it finds an object with this name, what it will do, it will go to that function, okay, and go inside that function and checks what is the code, and it will start executing that code and returns the value. That's how it will work. But the major difference between function and procedure is that, as I said, procedure will also store the code, right, as the function. But the major difference is that when you execute a function, it will compile this code each and every time. Compile as in, what happens when you execute a query? Let's say I execute this query. What happens? First of all, this query or any query will be sent to the SQL Server engine. There is an execution engine, like how we have the database engine. There is inside that there's execution engine also. It will take care of executing the queries. When you send a query to the execution engine, it will analyze it. First of all, it will check for the syntaxes, if there are any issues with the syntax, and also the object names being used inside that query. If syntax is correct, object names used are also present, then it will start creating the execution plan. But before creating the execution plan, if the syntax is incorrect or the object that you're using inside the function or the procedure or the query is not available, it will throw error like this. Okay, for example, let's say I'll type something like this again. Syntactically it is not correct, right? What it will do? It will first check for the syntax and it will throw error even before executing this function. And even if the name of the object is also not correct, then it will throw this error, correct? But if the syntax is correct and the object name is also present, it will show you the result. But before showing the result, what it will do, the execution engine will create an execution plan. It is like a blueprint of how that query gets executed. Okay, it will create multiple blueprints. It will create multiple plans to execute that query. Maybe 50, 100 based on the feasible solutions. It will create those many plans. Out of all those plans, it will only pick the best one in terms of using the less resources and consuming the lesser time. It picks the best execution plan, best blueprint to execute that query, and executes it according to that. Right? This is the normal process. Executes it, and then the result is returned back to you here. Okay. In case of any regular query, let's say I have this query. If I execute this query, for this query, it will always compile and create multiple execution plans, chooses the best one and executes. Every time I execute this query. Okay, or every time I execute this query as a query if you execute. Okay. In case of the functions also, functions, views, and as an independent query, every time you execute a query, it will check for the syntaxes, it will check for the object names, it will create multiple execution plans, chooses the best one out of them and executes according to that and gives you the result. This is the normal plan. But with respect to the stored procedure, what it does, it will compile only when you create the procedure or only when you execute it for the first time. And out of those 100 execution plans, it will choose the best one and it will store it. Okay, there is something called cache plan where the plan to execute that query inside the procedure gets stored. And after that, subsequently, anytime you execute that procedure again, it will use that already stored best plan itself to execute it always, so that your execution is faster. Because it doesn't have to compile the code each and every time. It doesn't have to create multiple execution plans and choose the best one. It has already stored the best plan. It will use that and executes it. That's why stored procedures are faster in terms of execution. And the stored execution plan gets changed only when you alter the procedure. Until and unless you alter the procedure, it will store the execution plan and it uses the same execution plan every time when you execute the procedure. That's why the execution of the stored procedure is faster, and that is the major difference between the functions and procedures. Clear? And for your curiosity, what is execution plan? Right. So let me do one thing. Let me take this query. If I execute this query, okay, I am in the other database, right? I'll change it to AdventureWorks 2022. So this is the result I'm getting. Execution plan. What is execution plan? If I execute this, here you see these icons. This one, these icons here. These two icons, okay? If I hover my mouse on it, this one, it says include actual execution plan. This is actually the actual execution plan. This is the include live query statistics. Oh, sorry, this one. This is estimated execution plan. If you hit Control L, you will see the estimated execution plan. If you hit Control M, it will show you the actual execution plan. Let's say I'll hit Control L, or I click on this one, this icon. Instead of execute icon, I'll click on this icon. In the result window, just notice. Can you say this? This is the execution plan. How do we read this execution plan? I mean, this is little overwhelming at this stage, okay, but just for your information, there is something called execution plan exists like this. How do we read it? From left to right, top to bottom. So now when I execute this query, under the hood, what happens? Under the hood, it executes like this. What it does, first see here, it is doing something called clustered index scan. So if you have the index created on this table, it scans that index, then it does the compute scalar, hash match. These are all the internal functions, and it sorts the value because of the group by. Then before this, it also does this cluster index seek on the employee table and the index seek on the salesperson, and it combines these data from these two tables using the nested loop operator, which is inner join. The inner join, left join, right join, outer join, full outer join we have, those are the logical joins. Okay, virtual joins we can call them as logical joins, but physically there should be a way to physically match the data, right? So that's when these nested loop come into picture. There are three physical joins also. Okay, one of them is nested loop, using which the data from two tables gets combined, and then there is something called merge join. This is also a physical join. To combine the data from these two tables, nested loops physical join is used. To combine this data with this already combined data, there is merge join, physical join is used. Okay, then all this data from these tables will be combined with this using the nested loop join. Then there is constant scan, again that is combined using this nested loop, then compute scalar, then the result is shown to you. This is how it executes internally. Okay, and this is the execution plan. And like this, whenever you execute a query, it will create hundreds of execution plans like this, out of which it chooses the best one and executes the query according to that. And this plan gets stored, the best execution plan it chooses gets stored for the stored procedure, so that execution of the procedure is faster. Clear? Any questions? How you display the execution plan window? So you need to, instead of when executing the query, what you do is select the query and click on execute icon, right? Instead of that, you can click on this one. This is estimated execution plan, but if you want to get the actual execution plan, you need to click on this and then you need to execute the query. When you execute the query, along with the result, you'll also see the execution plan tab here. Here it will show you the actual execution plan. Okay, to see the actual execution plan, you need to enable this icon and execute the query, because it has to execute the query to show you the actual execution plan, right? But this is just the estimation execution plan. Without executing the query, it will just show you what is the estimated plan. Is this the best execution plan for the function? I'm not sure, could be. Anyways, so do not worry much about these execution plans right now, because there is a lot to learn about these as well. For example, there is something called clustered index scan. What is clustered index scan? First of all, what is scan? There is something called scan seek, right? See here it says clustered index scan, and here it says clustered index seek, right? And here there is something called compute scalar, right? And here there is something called sort, here these nested loops and all. There is a lot to learn about these as well, but at this level, do not worry much about this. Just think that there is a plan gets created, the best plan gets stored for the procedure, and using which every time you execute a procedure, it will execute. So compared to the functions and other queries, creating this execution plan, the time for creating the execution plan is saved. That's why the procedures are faster. Okay, and also if I just hover my mouse on this, let's say on this, see here you'll get whole lot of statistics, like what is the physical operation, what is the logical operation, actual execution mode, storage, number of rows read, number of rows, actual number of rows for all executions, and estimated operation cost, estimated IO cost, estimated subtree cost, estimated number of executions, and what is the size of the row. There are so many information it gives, you can use all of this information later to optimize your query. If your query is not performing better, you can use this information and optimize your query to optimize your query to get the better result in terms of the time and the resource utilization. Okay, fine. So that's about the execution plan, and that is the difference between stored procedure and function. Stored procedure, functions, every time you execute a function, it compiles a query and creates multiple execution plans and chooses the best one and executes. Whereas stored procedures, when you execute it for the first time, it will create multiple plans, select the one, stores it, and next time, subsequently, every time you execute the procedure, it will use that stored plan and executes the query inside the stored procedure. And when that stored plan gets changed, when you modify the procedure, when you alter the procedure, okay, that is the major difference. And the second difference is that if you notice, for all the functions that we have created earlier, this returns is mandatorily we are writing. It is returning. Any function you write, it has to mandatorily return something. Whereas in case of stored procedures, it is not mandatory to return something. That is the second difference. Okay, and in the functions we have used these parameters, right? Input parameters. We are giving the parameter value to the function, which is why this is input parameters. Similarly, we have input parameters for the functions, but along with that, we also have something called output parameters. Means using this input parameters in the function, you are sending the value inside the function. You are sending the value inside the function. Whereas output parameters, you will send the value from inside of this inside of the procedure to the outside query. That is the output parameter. Okay, so in procedures, output parameters are also available, whereas output parameters are not available in the functions. Okay, so there are many other differences also, but these are the main differences. And one more important difference is that if you notice here, this is my main function, right? Inside that I'm calling another function. So which means I can call a function within another function. Similarly, I can call a procedure inside another procedure. I can call function within the procedure, whereas I cannot call the procedure inside the function. This is another difference. I can call functions, means call as in execute. I can execute function inside the procedure, whereas I cannot execute the procedure inside the function. This is another major difference. Right? Now, let's create some simple procedure to understand this better. Let's say, for example, I'll take this query only. I'll take this query. Create procedure. SP means stored procedure. Call this as revenue by salesperson. What is the syntax for the creating? Create procedure, procedure name, then as, then begin, and inside that I'll have to write my procedure logic. What is my procedure logic? This query. Okay, so I'll execute this procedure. Procedure is created. And how do I execute the procedure? For function, I use it in the select statement, right? But for the procedure, we need to use a keyword called execute and then procedure name. Either you can type completely execute or you can just type exec. This is also fine. So when I execute this, it is returning whatever I have here. Okay, so I said it need not return anything, right? So let's say I write a statement here. I'll insert this data into a temporary table like temp, for example. I'll alter this procedure. I'll add it below here so that we know what change we have done. Alter. I've altered this procedure. Now if I execute here, see, it is not returning anything because the statement that I've written inside is only inserting the data to this temporary table. And after inserting it to it, let's say if I do select top 10 star from temp or whatever, then it will return something, because this one will see at the end I'm inserting the data from this query to this temporary table and getting only the top 10 records, so it is showing the top 10 records. But if I comment this, if I don't want this, I alter it, I'm just inserting into this table, execute it, it won't return anything. So returning something is not mandatory in this stored procedure. Okay, and you can notice here that you can use multiple statements. This is one statement, this is another statement. You can keep on writing the statements one below the other. Whatever logic you want to implement, you can write thousands of lines of code or any number of statements you can write. Okay, and procedures are very frequently used in the database. You can take any database for that matter. Okay, and similarly, like how we have created the parameter for the salesperson, we can also create the parameter for the procedures also. Let's say, let me copy this. How do I create the parameter? Same thing. We have to use open parenthesis, close parenthesis. Inside that, I have to, I'll give different name for it. Param. I'll have to use a parameter name. I call it as @salesperson. Okay. And I'll use where clause. P dot first name equals to, let's say, David. Or sorry, we'll give David when we call it. Here it is salesperson. Why it is giving error? Because we need to specify the data type for it. Okay, now I need to create this, right? Because this is a new procedure with this name. Okay, I created this procedure. And how do I pass parameters to the procedure? For the function, what we were doing within the parenthesis, we used to give value like something like this, right? And it used to execute. But now if I execute like this, it won't work. So for passing the parameters to the procedure, I need to use this parameter name, not within the parenthesis. After the procedure name, add the parameter name, use equals to sign, and assign the value to that parameter. So this value I'm assigning to this parameter of this procedure. So this value will be assigned to this one, and this is being used here, and it will return the query. So now if I execute this, okay, 1 second. Sorry, it is using the old procedure name, right? This is the new one that we have created. So the old procedure did not have any parameters. So that's why it says it has no parameters and arguments were supplied. The earlier procedure, it had no procedure parameters, but arguments were supplied to that. That is the error. So now I'm seeing it for David. So if I change it to Stephen, this is how we supply parameters to the procedures. Okay. Now, let's say I enter Praveen. What happens? It is not returning anything because in the salesperson table or in the person table, we don't have a value called person. So how do we handle that? We have to send a message, or we have to execute this query only if this person exists, right? See, for example, this is a simple query, that's fine. Let's say you have very complex query which is doing the joins from, let's say, some 20 tables. So without having this person in the database, if you run that query, let's say that query is taking 20 minutes to run, 20 minutes to do the join and all that, or half an hour. So you're just wasting 20 minutes of the system time or the system resources, right? So before that itself, what I do, I'll check if this person exists or not. If this guy exists in the system, then only I'll execute the query. If not, I'll not execute this query. Correct? So what can I do? How can I implement that logic? I'll alter this procedure again. I'll call this as param1. I'll create a new procedure. Here in the beginning, what I do, I'll add that logic to check if that guy is already existing or not. Example, I type if exists, there is a function called if exists. I check select star from person.person where first name equals to this salesperson. Okay, if he exists, then only this query gets executed. You can also add begin and end here, but if you just have only one statement, then these are not required, begin and end. You can just skip this if you just have only one statement. Correct? Now I'll create this procedure. Execute this. Okay, it is still executing it. 1 second. Oh, sorry, because I am using the old procedure, right? See here, what it does, it says one row affected. If you see the execution plan also, it is just checking only this query, not executing this query. So thereby, we are not unnecessarily executing this query if the person does not exist in this. Let's say if I add David, now result, you see the result, because this guy present in this table, then only I am executing this. If you go to the execution plan, then now the execution plan is different. There are two queries, right? For each query, it creates an execution plan. This is one execution plan, and this is the actual execution plan, which is giving us the result, right? Else, let's say if I add, let's say Praveen or any other name which is not there in the database, it is not showing anything. As a user, when I'm executing, I don't know whether this guy exists or not. So what I do, if this guy exists, I'll execute this. If he doesn't exist, in the else part of this if statement, I print some message saying user or person doesn't exist. Doesn't exist in the system. Now what is happening? For text, right, we put the value in the single quote. But here, for this also, I have added this single quote, right? So it is considering only from here to here as the text, and after this, it is not identifying it. So it will fail if I try to execute this, right? I mean, I need to alter it. One second, let me. Here I wanted to alter, right? If I try to alter this, it will fail, saying that the syntactical error near this T. So if I want to have this single quote also as part of the text, you need to type one more single quote there. So that means it will nullify that effect and it will consider that as the single quote. Okay. So execute this. Now it is executed. Now, if I execute the query here, I mean the procedure, now it prints this message, person doesn't exist in the system. Similarly, like this, you can implement whatever logic you want. Let's say you're trying to do something, you're trying to load some table based on a condition. If that condition is met, then you load data to a table. If that is not met, you load it to some other table. Something like that. Fine. So we'll see one more thing before we wind up for today. I was talking about the output parameters, right? This is the input parameters which we assign inside the function, but if I want to get some value inside of the procedure to the outside world, then we use something called output parameters. Say I create a procedure. I call this as sp underscore check salesperson exists. Here I use one parameter called at salesperson, or maybe first name. Okay, this is the input parameter. So I'll create one more parameter called salesperson ID in. Here I'll mention a keyword called output. Parameter name, data type, and the keyword called output. That means this is the output parameter. So what I want to do in this procedure is that I'll call procedure like this and I'll enter some name. If that person exists, then I'll get the person ID back, okay, from this procedure. If that person doesn't exist, then I'll print the message as person doesn't exist. Okay, so here as begin, end, inside this, let's say I use something like this, set salesperson ID equals to, for this I want to assign salesperson ID from the this table, right? So I use these joins, select r from sales.salesperson sp join human resources dot employee e on. You need to check these tables later, right? Like why I'm using human resource employee. You need to check the relationship between them. Without business entity ID, join person.person e on e dot business entity ID equals to e dot business entity ID, where e dot first name equals to this parameter that I specify. Okay, then if salesperson ID is not null, that means if I have assigned some value here, then return salesperson ID, else print person doesn't exist in the system. Okay, so this is the procedure that I have created. So what I'm doing here, I have one input parameter and one output parameter, and you have to use output keyword to indicate that this is the output parameter. So this input parameter I'm using inside the query to supply value to inside this to supply value to that. Okay, sorry, here I need to use sp underscore business entity ID. So I'm using this input parameter to supply value to this query, and this query returns some result if this exists and is assigned to the output parameter. The salesperson ID is assigned to this output parameter if that person exists here. If not, it will have null value. So I'm checking if it is not null, that means if that person exists, then return the salesperson ID which I've assigned here. If not exist, I print this message as this guy doesn't exist. Okay, and this is the procedure. Execute this. Now how do I execute this procedure? Exec procedure, and the input parameter first name, let's say David I use. Correct. So if I just use this, it will throw error saying that it expects another parameter which is salesperson ID that I need to use it here. So how I use it? Anyway, this output parameter will give value from the procedure to the outside, right? So I use it here. Procedure. It will give value outside. So it will give value outside. See, for this one, for input parameter, we'll assign this way. This value is assigned to this, whereas this is output parameter. This has to give the value outside. So here I need to capture its. This is giving the value and the output parameter. So it is giving out the value. I have to capture it here. So to capture it here, I need to create one more variable and use it in that. Capture this value in that variable and use that below. Okay. So to capture the output value, what I do, I declare a variable. Declare at, let's say, SPID, salesperson ID, int. This output value are assigned to this variable, and I have to use output keyword so that this is output value. This is, I need to use comma also. This value is assigned to this. Now, if I do select this SPID where I have my output value, if I execute this, now it should work. If I use David, let's say if I use, call this as a salesperson ID. If I use Praveen, what happens? Null. And if you go to the message, here it shows person doesn't exist, as well as result of this query is null. Clear? This is how we use these output parameters. How can I use this? Let's say here inside this function, right? Inside this procedure, I can call this procedure, which will return the salesperson ID, and I can use that salesperson ID here instead of that. Here we are checking directly, right? Instead of that, what I can do here in this case, I can call this procedure and check if this SP ID, salesperson ID, is null or not instead of this. If it is null, then I'll exit. If it is not null, then I'll add, instead of the first name, I'll add p.business entity ID equal to salesperson ID and execute this. So this way I can also call this procedure inside this procedure, right? So that is a homework for you, to call the procedure instead of the same logic. This logic that I've implemented here, this has to be implemented using this function. You need to call using this procedure. You need to call this procedure inside this, in case of this, and make use of the output parameter and assign that output parameter value here and make it work like this. Fine. So this is about parameters. I mean, this is about the procedures. The simple fundamentals of the procedures is only this. So inside this, what you write, it is up to you. You can write 10 lines of code, 100 lines of code, 1000 lines of code. I've seen procedures where there are 20-30,000 lines of code also, which were running for 5 hours, 6 hours. It depends on you. It is up to you on what you want to implement inside this procedure. Okay, all good? Okay, fine then. So if you do not have any questions, we can wind up today's session. We'll join back again tomorrow and see what else we can do. Thank you so much for joining. Have a good day. Bye bye.